Hello, love. Very unfortunate to go after Guillermo's demo, but here I am. This is a talk that I am giving for the first time. I think Georgios came up with a title, so I tried to fit the talk to the title. But the question is, working within a space that has so many standards and protocols that you can pick from and try and leverage to build really good experiences, how do you actually make good use of these? Don't lose yourself in the idea maze that's available to you, but also future-proof the infra that you're building or the product that you're building in order to actually make use of these protocols in productive ways. So the other title, alternative title, might be how to tame protocols to build lasting products in a fast-moving space. It's a little bit less catchy, but broadly, I'm Henri Stern. I'm the co-founder of Privy. We build embedded wallets and onboarding infrastructure so people can access crypto rails much more easily. The goal is to enable developers to build secure experiences that enable any user to own assets directly within their products. And so I'm excited to talk about some of the lessons that we've learned trying to leverage protocols to build really great developer tooling and in turn enable great UX. So why does this matter? I think done right, you get to ship better products faster. You get to have future-proof infrastructure that will not go sort of out of date, even though the space that you're operating within is changing very, very quickly. So done right, if you leverage protocols, you basically get to leverage new developments in the space easily as they come out. For example, DeFi is moving at an incredibly fast pace. You don't want to have to re-architect your product to leverage the latest advance here. You should have a stack that is future-proof to the work that other people are doing in the space. That's arguably the entire point of these open systems. And likewise, you should not sort of hinder yourself by picking the wrong abstraction and then finding that you've built yourself into a hole a couple years down the line and you have to re-architect your entire product. So this is what hopefully being thoughtful about protocol selection gets you. Conversely, I would argue that done wrong, this will destroy you. And this will destroy any chance you have at shipping anything at all, let alone a product with good UX or good DX. So done wrong, you will not ship. UX will become sort of a slave to the technical constraints that you've picked out up front. And broadly, you'll pick your audience based on the tooling available to you rather than the other way around. So I care about this partly because of my work at Privy, and before this, because I was a protocol researcher at a company called Protocol Labs. I worked on a system called Filecoin, which is building basically long-tail storage marketplace on top of distributed systems. And I think what I saw there was these incentives that we build in crypto are incredibly powerful, but if misused, they're incredibly hard to use. So there we go. Taking a step back, and I promise this is the end of the shilling, I kind of posit that the entirety of our work at Privy is about enabling access to protocols for users. We build basically the abstraction stack that enables flesh and blood individuals to access distributed systems and crypto rails without having to think about the stack and set of protocols that are on top of it. And I think Georgios talked about this in his intro. By and large, having to get a computer science PhD in order to use basically digital ownership rails has been a major hindrance to the space, and how we get to translate these things is incredibly important. And so I think a lot of our work is an exercise in balancing the tension between picking the standards and working on top of the standards that power the space, but not being so beholden to them that we actually sacrifice things that enable people to actually use these products meaningfully. So I'm going to use a case study for this talk, and broadly, the case study is embedded wallets. So embedded wallets are really an abstraction that enable any developer to spin up self-custodial wallets for any user coming in without forcing the user to download an extension, save a pass, a mnemonic, or otherwise think about the fact that they're doing fairly advanced cryptography under the hood of what they do. The three sort of design targets for us are the wallets have to be secure, they have to be extraordinarily flexible and performant, and they have to adhere to the self-custodial guarantees that we set out. The owner of the wallet should be the only party that can access the wallet's keys. And sort of the optimization for us is how do we make this as smooth an experience as possible for the developer building with the system, but also for the end user benefiting from it. And the constraint is we don't want to have to redesign this every single time a new advancement comes out in the space underneath. So without further ado, I guess, some lessons building embedded wallets. It's a study in 4 parts, and I tried to make this as sort of protocol-centric as I could. So the trigger warning is, unfortunately, I guess there's a lot of Ethereum here, so there will be acronyms and numbers, and hopefully we'll lean into it, but there's a bit of alphabet soup. So leaning into that, I'm actually going to work my way up the stack and look at how do we build basically from a core architecture in picking the protocols that we need for key management and distributed key management in order to ensure self-custody, to the developer experience actually leveraging the system that we've built, all the way to then the extensions that we can build on top of embedded wallets to make sure that they interoperate with the space as market needs evolve. So this will get somewhat technical, but we'll see. So chapter 1 is follow the user. Ultimately, the core lesson here is that the protocol choice up front will end up kind of pinning you to a, call it window of performance trade-offs that you're going to have to stick to. And so it's very important to be very clear about the product requirements that you have as you set out to build. So for us, the goal, and I want to make sure that all these stories are kind of grounded in, how are you thinking about what you're trying to get out of the protocols that you might leverage? The goal is to have secure, performant infra. And I talked about this before. This is how we power, ultimately, the underlying systems of the embedded walls. This is how we make key management accessible to users who otherwise don't care about key management in a way that they are the only party in control of those keys. So for us, Privy's core architecture combines 2 core technologies. This is TEEs, secure enclaves, in which all key reconstitution happens, and key splitting via Shamir secret sharing. So we basically, whenever a wallet is created, split keys immediately, and then we help orchestrate sort of key share management to ensure that keys are only ever reconstituted in an environment under the appropriate owner's control. So only the owner has access to the wallets themselves, and this is cryptographically enforced. But there should be enough sort of flexibility into the system that we are able to build this for different types of owners, businesses, individuals, servers, agents, and so on and so forth. So the 3 choices that we had up front in terms of technologies that were kind of available to us, and each of these are protocols, as it were. One was TSS-based MPC, so threshold signature signing, what people commonly refer to as MPC in the space. The second was Shamir secret sharing. This is like an old cryptographic workhorse. I think the paper's from like 1972. Broadly used across every password manager that you've ever played with. I think HashiCorp Vault uses it. Cloudflare has some on some of their secrets management products. And then the third is TEs. They come in many different flavors. I think you want to be very mindful of which type of secure enclave you use. But there's been really good advances with like sort of enclave virtualization across the Amazon cloud and Google Cloud recently. So it's become a much more viable technology. So we looked at this, to give it up, we used basically a split of TEs and SSS. TEs give us an extraordinarily performant, flexible environment in which to do all key reconstitution, but SSS gives us the ability to actually have variable sort of trust, which is to say we can split the keys and have the shares be distributed amongst the appropriate parties to ensure that the right people need to approve reconstitution in order for any keys to be regenerated on behalf of the end user. So why this, and why not MPC? And this is where I'm going to go into maybe some spicy takes. And ultimately, I think that the main thing I'll say, to be a little bit more PC, but I happen to believe this, is that protocols evolve, and the stack you build should evolve alongside these protocols. As trade-off spaces change, you should be able to change the underlying protocols that make up your product in order to adapt to best-in-class like tooling today. At the time we made this decision, and I believe this holds today, the core concerns with TSS-based MPC, which has advantages as compared to the solution we picked, namely the advantage is the keys are never reconstituted, so there's no single point of failure. We're dependent basically on a trust assumption with TEs, which is that the secure hardware doesn't get breached. If that goes away, then anybody with access to servers has access to secrets. TSS does not have this flaw. There's never any reconstitution. It's basically a putting together of multiple signatures to generate the end signature from the wallet in a way that doesn't have this. Unfortunately, it has 2 core issues that we felt were sort of dead on arrival. The first is speed. We serve a lot of trading apps. We serve a lot of consumer products. And going at it from a product requirements, multi-second signing times is not possible for a lot of our customers. The second is security. Whilst the theoretical security of a lot of the MPC systems is superior, this is a very new algorithm. I think the first paper with a viable TSS scheme is from 2017. It's by this fellow called Yehuda Lindell. And you just won't have had as many reps building basically with TSS-based MPC as you would other architectures, which means that I think, at least so far in 2020, 2021, 2022, and 2023, there have been basically hacks found in the largest TSS-based MPC libraries. Protocols take time to mature, and you don't want to be the first to test out security primitives. So with that, we'll come to our first lessons. First, protocols set a baseline. If you have to fight your protocol in order to get to your product requirements, you are going to spend your life basically fighting your own product. Here, I've kind of grayed out the competitors. This is very self-serving, but these are citing latency tests that we did basically on the core architecture before optimization. So at the time, we have, for example, co-location of servers in the main geographies that we serve, which shave off the majority of the 300 millisecond signature average here, because that's like network round-trip times. But basically, pre any optimizations, these are the sorts of times that you see. The first two here basically use a mix of either on-device or TE-based architectures. The back two use MPC, and it shows from the, I guess, 2.5 second to 5.5 second latency that you may need from this. So again, be very clear about what are the non-negotiables in your product requirements up front. Otherwise, you're going to spend your life fighting the protocol that you're trying to build on top of. The second lesson is protocols need time to mature. This is not to say don't be an early adopter. This is to say early adoption comes at a premium. Be super, super, super clear on why you need to be an early adopter, because if you don't, it's better to let other people chew through this. This is a bit of a coward sentence when it comes to protocol design, but you don't want to be the first party that has to run into production bugs on security systems. And I think Fireblocks, which uses MPC, has decided that this is one of the core things that they are going to be great at, and they are. And it just has become a focus for the company in a way that few others can actually do. So again, I think this is one of the many issues that have existed in open source like MPC libraries, but a reason why you might not want to leverage them unless you are actually prepared to really invest in the systems. All right. Second story, we're going to go up the stack. So we're actually going to look at what does integrating an embedded wallet look like. And here the lesson for me is hitch a ride. If there are protocols that you can lean on to ease basically adoption of your tooling, you absolutely should. And the goal is to build idiomatic interfaces for wallets. So I think one of the best early decisions that we made at Privy was making our embedded wallet systems 1193 providers. Now, what does that mean? EIP 1193 is the set of RPC methods or calls that wallets have to adhere to in Ethereum. It's an insanely valuable standard because it basically makes it that you don't have to fight basically every third-party wallet provider, from MetaMask to Rainbow to all of that. They all adhere to the same standards. As a developer integrating wallets, you just need to make sure that you support these RPCs and you're good to go. And I think we definitely weren't the first people to build embedded wallets, but to my knowledge, we were the first to actually be very, very stringent about adhering to standards that every other wallet played to. And the point was to say, by doing this, our embedded wallets are not toy wallets. They are functionally indistinguishable from MetaMask and from any other system, and that gets us three things. It gets us better UX for your users, in that a user is a user no matter how they come in. If your user is hyper-crypto native, if your user has all of their assets in MetaMask, they're probably not moving away, and they should be able to come in with a system that you've built. But if your user doesn't know or doesn't care about crypto, you shouldn't have to force them down that path. And yet, for you as a developer, you need a set of interfaces that can respect all of these users. So that's the first piece. The second is better DX. Obviously, you don't want to force, unless you can help it, your early adopters to have to rethink their mental models for how your product works. So being able to piggyback off of existing standards makes adoption of the tooling much, much simpler. And finally, it actually future-proofs the product because, again, as you think about Aave, Morpho, Kimono, all of these different yield generation protocols in DeFi as an example, these are folks, Camino, not Kimono, these are folks who are working off of existing standards, and you want to be able to basically have them work out of the box. And adhering to the standards that exist in the space gives you that. So lesson 3 is where you can lean on existing protocols it will completely ease adoption of the tooling or the setup that you have. And I think this holds, obviously we're talking about developer tooling, but this holds in terms of UX. Don't reinvent patterns. I think one of crypto's major flaws was forcing people to go through a connect button on the top right. A lot of people don't want to do that. It should be an option to those that want to, but if things are working on the internet in a certain way, unless it is your core mission to reinvent that pattern, don't reinvent the pattern. Let people connect to your systems in the way that they're used to. Our third story, I'm going to try to speed up, is stay loose. Don't overbundle with protocols early. So I want to nuance the earlier point I made about not being an early adopter. I think it's important to use tried and tested protocols, but I also think it's important to lean into abstractions as they improve. And so the question is, as you try and do both, how do you actually do this in a way that gives you the appropriate margin for error as protocols kind of harden over time? So the goal here is gas sponsorship, put very plainly, and a core functionality of Preview wallets is the ability to integrate with other on-chain systems, smart accounts, multi-sigs, and different tooling there very, very easy. And this is a story really of two protocols. On the one side, you have ERC-4337, which is a smart account standard that defines how you can basically build user accounts where the wallet itself sits on chain and has a signer that the user holds to act on behalf of this wallet. And the second is 7702, which is a newer standard that basically tries to enable custom validation logic for transactions without requiring an on-chain account, but basically by having EOAs be able to use that on-chain validation logic directly. Now, if you were anywhere near ETH Denver circa 3 years ago, and you were not working on 4337, you were wasting your time. And you were working with outdated tech, and the world was going to change out from under you, and there was no point in doing anything that you were doing with EOAs. Now, I think 3 years hence, the results are in, and that turned out not to be true. 4337 is a great standard. It's moved the space forward, but also it is a very small part of actual blockchain usage out in the space. And so I think a very real threat to people building tools is to jump too early on protocols that are still forming and still being shaped. And so I think one thing that we did really well here is try and balance basically how can we embrace protocols to make sure that our customers that want new sort of cutting edge technology can get it without building ourselves into a corner should the world shift in another direction. And so what did we do here? First, and this is what we're doing with 7702, we're following the same playbook, you want to gauge interest. Give people early, easy ways to start engaging with these things. We build basically we do a lot of dog fooding with these protocols, and this is a guide that we have for integrating with EIP 7702. Again, because we follow standards, everything is compliant already. But we're going to ask our developers who want it the most to actually help do this integration with us so we can learn from their experience and figure out how to model this better. Second, from there, you can sort of optimize and make the setup of these integrations better. So this is actually what happens with our 4337 integration, and the same is happening right now for 7702, is we basically bundle the two. You've got account creation, when a user comes into your app and creates an account and ultimately a pair of signing keys. Now, by default, this creates an embedded wallet, an EOA that they can use to hold and manage assets. But if you've turned on the smart wallet module, in a sense, they were basically piping this into a smart account system, whereby the account creation will also sort of spin up a factory in order to create the smart account, and then set up the embedded wallet as a signer into that factory so that the user can basically by default do this. And so this abstracts the complexity of the smart account from the developer wholly, but it doesn't change our interfaces fundamentally. And this is the third thing, is there's protocol development on the one side, but the second is there's infrastructure development to serve the protocols. So what you have here is a never-before-seen screen with Ithaca and the integration of 7702 standards into the same space. But broadly, what we do is we enable developers to pick the smart wallet providers they want to use. So the drop-down here has different factories that developers can pick from in order to spin up their smart account contracts. And then from there, you can actually pick your own paymaster and bundler URLs so that you get some choice around the interface. Because again, this is a sort of two-sided risk if you're looking at future-proofing. Have I picked the right protocol? And have I picked the right infrastructure provider who won't go out of business and have me rethink my entire sort of stack? So this is kind of how we've managed, in a sense, integrating developer protocols, which is making sure that you lean into these advances, but don't overbundle too early. and make sure you test the benefits of these things in prod before making them a default for your product and before forcing every user to have to interface with these. And finally, insofar as you can help it, try to build for composability. A lot of teams have great ideas about how to advance protocols. I think you should be healthily skeptical about whether or not it's worth making a breaking change in order to serve one sort of application or standards developer over the rest. With that, and I promise I'm almost done, don't wait for protocols. This is the fourth lesson. Protocols and waiting for protocols to be ready will kill you. And I argue will kill a space if it happens too quickly. And this is why, again, to Georgios' point, this is as exciting a time as I've ever seen in crypto in terms of people going and building things and moving the space forward in fundamental ways. So the goal here and the experience that I want to talk about is secure wallet delegation. It's an extraordinarily important part of UX that we're seeing come out as more and more fintechs and trading platforms adopt crypto rails. And it is one that has been, going through a lot of protocol work where I would argue we're still very much in the plasma form of universe formation. The planets have not yet solidified. So this is a story about session signers. This is what we call it, and delegated permissions in Privy. And broadly, the question is, how do you delegate access to your wallet to a third party that can act on your behalf? So for example, here this is a very simple thing. A user spins up a wallet, delegates access to the wallet in a permissioned way to a third-party app signer. And this could be a platform that wants to do dollar cost averaging on your behalf or portfolio rebalancing on your behalf. Or this could be, and this is happening more and more, an agent that wants to trade on your behalf, that wants to do micropayments for you if you give them a budget and allowance as they surf the web. And so, how do we actually do this in a decentralized, verifiable way? So, circa 2023, 2024, this is the standard space. And the broad idea is you are seeing sort of a war to own the standard and the guidelines. And this is a very good thing. I think it's very easy to see this cynically. But reality is these are very deep technical questions that are being asked by these teams that are disagreeing about the way in which these things should work. And you're seeing this, 7715, 6900, and then a few variations of Coinbase systems all vying to be the default. So what did we do? We basically said, this is great. You should be able to integrate these. But also, let's have an off-chain version of these protocols so that we're not hung up on moving the space forward while the standards coalesce. And so we actually built a standard of our own into secure enclaves to enable basically tight policies and delegation in a way that is chain agnostic and that doesn't basically depend on a standard being agreed to. And the idea is that very quickly you can move these permissions on-chain or off-chain, but you're not stuck waiting for the right on-chain protocol to emerge in order to do this. And so this is the last lesson, is don't delay shipping a protocol. Think in terms of protocols, but experiment with off-chain where you can. So with that, I'm going to conclude. I think the delta and the gap between UX and protocols, I was looking for this picture, or picture of this side. And if you want to find it yourself, the Google term, which I think is very poetic, is called paths of desire. When the UX basically is broken and the user or the developer ends up charting their own course through what you thought they were going to do. This is apparently called a path of desire. And I think basically protocols are trying to approximate future paths of desire and look at what will the space seek to enable and how can we codify this. Sometimes they get it right. Sometimes they get it wrong. And I think as with art, great protocols will kind of outlive us all and prove to be extraordinarily sticky. This is the case for TCP/IP. And as with art, there's a ton of shit out there, and you should be very, very wary of buying what you think is a masterpiece, and actually you've just bought a dud. And so the sort of final lesson for me as we work in a fast-moving space is this lesson from a book that I like. The more dynamic the situation, the poorer your foresight will be. Don't try and predict the future, but try to build optionality so you can actually move in this uncertain world. And so with that, I would say lean in to using protocols because they will accelerate your product, and maybe most importantly, they will give your users superpower as the space continues to expand. This is what's so special about crypto. But on the other side, make sure that you price the protocol choices you make, and don't tell yourself that you should be waiting on a protocol to happen in order to build your product, because it is almost never true. Thank you.
Yeah. Any questions for Henri?
Yeah, great talk. A big fan of Privy, and we're also using Privy for a lot of products. So quick question, because we have right now we have tons of probably dozens protocols, right? Do you have sort of some strategy in the future to automatically or to onboard into all different protocols, even sort of the virtual machines are different?
Yeah, it's a good question. I really think it depends on the flavor. At least what I try to do is figure out an ontology for what are these protocols good for. And so, for example, we've had to think about this in terms of chain support, where we've tried to figure out what is a tiering system so we can unblock developers using Privy very quickly. If they want to use an exotic chain that they're the only ones to use, they shouldn't be stuck on us, and we should offer basic key management. But then from there, we should have abstractions that kind of layer up to giving them a policy engine, webhooks that react to on-chain events, and so on. And so the honest answer is, I think we have a strategy on a sort of categorical basis. So we have a strategy for obviously new protocols as pertains to chain support, for new protocols as pertains to spend permissions and gas sponsorship. And these we typically build out by basically doing one or two manual things first. So for gas sponsorship, for example, the EVM and the SVM story are very different. So we basically try to make sure that we build always with two things that are different up front, so we don't overfit to a single protocol. And then we try to generalize that ontology so it becomes easier for us to adopt other protocols. But the goal under the hood, and this is something that we're actually building out right now, is to completely abstract away the protocol. At the end of the day, the early adopters will care that you're using 4337, 7702, or whatever else it might be. But most people just want to put in a credit card and think that they don't have to care about gas anymore. And so this is one space where I actually think the space is matured enough that we can provide that experience now and actually abstract away the protocols for the people who don't want to. I don't know if that answers your question, but amazing. Oh, I don't know if.
So we're moving into a world where machine-to-machine payments are becoming more and more frequent. So how do you think about designing wallets not just for human users but also for AIs and delegating to AIs and all of that sort of interaction? Might this be different from, let's say, just getting an everyday user on board?
Yeah, I think this has been one of the most delightful things I've found working on Privy, which is you can find very different customers whose needs actually, if you look at it through the right abstraction lens, are corresponding. And so the example here is we had a lot of agentic trading customers that came to us and said, I want to enable agents to trade on my user's behalf. I want to have them run strategies, basically, that the user should be able to benefit from when the user's not around. How do I do this securely? Because obviously a hallucination is going to completely wreck my user and their balance. And so this is where we started investing very heavily in a very granular policy system. And since then, we've actually found that financial institutions, banks in particular, actually really need these same policies to codify the sorts of risk management they have on, we want a manual review on any wire being sent out over $1 million or things like that. So that's a small aside, but actually, very interestingly, I think a lot of what we're seeing on the micropayments and agentic space corresponds to problems that we're seeing elsewhere. I think the big change is going to be, threefold. And one is unresolved, in my opinion, and two are mostly works in progress but resolved. The first is obviously policies. How do you account for failure modes, basically, and how are you a little bit better about defining a very clear threat model for the agent going off the rails? And I think that's broadly a solved problem via policy engines. I think there's some, mileage will vary depending on how on-chain or off-chain you seek to be, but we know how to handle this, and it's a mix of API-based policies via transaction simulation, because there's 1,000 ways to drain a wallet, and so any sort of signature-based or call-based policy there is going to fail. And then enclave-based policies, in our case, to verify recipients, allow list, and so on. The second problem is communication with the agent. And here, obviously, MCP does us all a great service. We have support for MCP servers, and broadly, I think that's also a solved problem, which is how do you get the agent to actually understand what the wallet is? I think the unsolved problem, and there's some cool space happening cool work happening in the space. I think of a few teams doing really good things here, is authentication. I think agent to wallet authentication remains super fucking gnarly, because short of giving the agent a private key, which has its own set of risks, there's really no clean way to do this. And this is something where we've sort of been stumped on how do we actually build really a foolproof, secure authentication system whereby the agent has access to the wallet on the appropriate basis, but does not risk leaking that access to a malicious third party. And I think for the most part, right now, the sort of poor man's way out is better policies. Let's make sure that if the authentication systems fail, it's not that costly. But that I would say is the biggest unsolved problem. But we're seeing a lot of exciting stuff there. And we were bought by Stripe fairly recently, and obviously agentic commerce is something that they're very excited about. So lots more coming there.
All right. Give it up for Henry.
Thank you.
Amazing. So Privy, I think, is one of the biggest success stories in crypto, and I think they have done, that was dangerous. I think they have done more than most of us to advance the state of crypto.